Embracing complexity, that's clearly a challenge. I think a number of people have mentioned that today, especially when you don't know what systems are going to do. Ecosystems, take, for example, something as simple as the delta works. It was considered one of the 7 wonders of the modern world, with dikes and sluices. But the interesting thing is here that during the process of building these sluices and dams and everything else, people became aware of environmental concerns. They were not part of the requirements. They weren't part of what was being designed. Engineers were stopping the water flowing over the Netherlands. We are underwater, so it did make sense to do that, but nobody took the environmental concerns into account at the beginning of these projects. It wasn't until they discovered the implications that the sluices were built differently. So the initial sluices are built with different technology than the later ones. We still have problems with flooding, but controlling flooding, I should say. Another thing is the systems that are needed to rely on self-organization. For example, during the first 72 hours after a disaster, you need to bring together systems of systems with large numbers of uncertainties, requiring cooperation and coordination, and thus governance. You can't have a system without the governance. Continuous change, and again, that unpredictable behavior. You don't know what people are going to do. They do have different objectives and preferences that you don't know ahead of time, and you can only discover when they're actually using your system. And the main point is there is never a best solution. That is something that students fail to understand. We have an optimal function, you use the function, you know the best solution. Well, no. You know the best solution given the constraints you're imposing upon yourself. You do not know it's the best solution. It's the best solution you can come up with right now that's satisfying. So in my version of the world, we need to design these systems. We know that the world's continually changing. We know that the best solution. We know that people will organize themselves as they go. The only thing we really have are the values. When we're designing a system, and yes, it's an intervention in an existing world, but when you're designing a large-scale system, a social technical system, you have to start from values. They are the only things that will stay in place, your mission statement as well, and you'll try to come up with the requirements that match that. So as we know, and Cottelaine said something similar, the values we learn learning on prepare us for our future, and as our situation changes over time, so does the way we interpret values like this, but they are strong. So connectedness, autonomy, responsibility, self-efficacy, feeling safe, feeling loved, these are values that we share, often during the different phases of life. Survivability. These are human values that we embrace, and they determine the way we pursue our own well-being. For social technical systems, we design systems with very similar values, with slightly different meanings in most cases. For example, systems designed for sustainability, you're taking sustainability as your main focus when you're designing a system. You need to operationalize it, decide what you actually mean by that. You're designing for sustainability. You're designing for good, or you're designing for participation. Cottelaine used that slide during her presentation, but we believe that the 3 main values, if you want people to participate in a system, are trust. If you don't trust the system, you can't use it. That entails a need for security, etc. But That's part of it. You need to be able to engage with it. And you need to feel empowered. You have to have the ability to act. You can't give people responsibility without the ability to act. So taking responsibility can only happen if you have that ability and if the empowerment's built in. These are 3 values stand independent of a domain, independent of an application that we believe and have shown over the past 15 years that are important. So within the Participatory Systems Lab, we've looked at many different approaches. I've had the joy to work with Eleanor Ostrom on polycentricity and what polycentristic governance is. This is Victor Ostrom's definition, basically multi-leveled governance, global management based on local coordination. For those of you who don't know his work, he looked at the police systems. Local police much more effective than a federal police force. And yes, there's all sorts of but being closer on the ground, self-organization works much better. These are the Olympic Games in Beijing. Those are people. And the only way this is coordinated is by looking people around them, actually similar to the work that was shown this morning. And we believe such systems entail a physical layer, the distributed ICT layer, but there's also software agents, and the social layer. And each one of these have different requirements, different interpretations of your values. So if I say I need safety, safety has different implications for each of these layers. So what does it mean to enable participation with these values? For health systems, safety, obviously, inclusion, engagement, fairness. This seems obvious, but if you see that the same word kind of continues down for all sorts of systems, you realize that what this actually means will depend on your specific system and your specific viewpoint. So my definition of safety may differ from hospital's definition of safety, or my question this morning about the taxis, the alternative for Uber. For whom is it safe? For whom does it feel safe? Can be safe, it feels safe. In Rotterdam, the most safe area, according to statistics, at least criminal activity, people experience as being the scariest, the least safe. So experiencing safe versus being safe are, again, 2 different interpretations of safety. Empowerment. We can say everyone has a voice, everyone can say something. That's not the way people experience it, and we're not enabling people to have a voice. So what does it mean to empower people? Education helps. What extra do we need to do? What does it mean? Housing, we'll go into that later. Mobility and energy provisioning is a very clear one. Energy justice is an area we do quite a bit on. What is energy justice? Equity, equality, questions like that. What does it mean? That I have access to energy? That's important. That I can afford it? That my house is insulated? All of these differences, what does it actually mean? So when you design a system, you need to translate it, but you have to start by realizing what your focus is. I do work in Toulouse with the aircraft design. Number 1 is safety. Full stop. Number 1 is safety. I don't like airplanes falling down. But what else is important? Energy efficiency is important. And then you get the deliberation between them. Safety is number 1. Okay, which considerations are we willing to take into account? Which discussions, which interpretations of these values? And now I'll look into a system that industry developed, supervised by Martijn Renier, Derek, and myself. Connectedness, fairness, inclusiveness, accessibility, security. So a disaster occurs, you have 72 hours. What's most important? Survivability is number one, but okay, we can't operationalize on that. So what do we need to accomplish? Communication, effective reactions to an incident during the first 72 hours. Well, it soon became clear that communication, of course, is a major issue, especially in the more remote areas. So what industry developed was a protocol, won't go into details here, the SOS system, that enabled people to share the power on their phone with each other, basically. So to communicate, right? So I have a lot of juice on my phone, but Derek happens to be in a position to communicate to someone further up. He doesn't have that much. So, and he has something to say. So he sends it to me and I have to send it away. So, but again, is this fairness, right? My phone was charged. It's mine. And I'm going to give it away for his message. No, she showed in this work that it's definitely worthwhile and that you can continue communication for a lot longer if you share a bit of energy you already have, because you're not going to be getting any other until the infrastructure is up and running again. So she came up with an infrastructure, less mobile ad hoc network, with an ad hoc network protocol to make this work. This is at the lowest level, well, level of ICT. So we're not talking about how people organize themselves in this system, not about which information they exchanged, but which communication channels they could exchange information using the energy that was available. To explain it well, industry? Okay, she probably would have said it slightly differently. And so her definition of fairness and inclusion was node participation, energy loss, load distribution. These aren't the normal interpretations of these values. We understand the value, but in this case, for a network like this and the connectivity, it translates to these aspects. So what we need to know is actually understand stakeholders' needs and desires. In this case, we didn't do field work. In the case I'll mention right now, we did. So we need to explore, explicate, and negotiate the individual stakeholders' needs, values, norms, and requirements. And we need to align them. That alignment was work that Katalin referred to. First, she referred to a methodology with which she used automated systems technology to actually extract the values. And she also discussed a system in which they negotiated the values. We did something similar with Trivik, who seems to have disappeared, in Hamburg, where they gather information from the citizens, all these statements, the idea, what do the citizens want? He came up with a machine learning algorithm to discover the concepts that were important and had experts look at it to decide which concepts were most important and how the town could go about using them, both in quantitative and qualitative. But in his case, he used, again, the technology to make this work. In other cases, for example, for information management in Jakarta, we've looked at the information exchange. So what information, or how is the information exchanged? And how do you measure the effectiveness of the exchange? The mission is to provide relevant, reliable, and verifiable, those are all norms, information to actors who need it, when they need it, in an accessible manner. It's a mouthful, but it really is what's needed. So those were the values that I named. Again, the interpretation. Once we know this, what does it mean? I'll give you two examples of where the literature and the theory gave us a definition, and that in field work, talking to the stakeholders, they came up with slightly different definitions. So, for example, timeliness, the degree to which information received is up to date. but no, before the expiration of the information need. That's the important part of it. Here, degree to which information received matches their in use, matches the use required level of aggregation and spatial location. They don't need information from someone down the road, and they need it at a level they can interpret it at. So those are examples of, this was another situation with farmers. How can we get them to work together to extract their needs and desires? And the way we did that was actually reflection through a paraphrasing technique that was very successful in organizing farmer organizations. So you see here is these workshops, the paraphrasing techniques, the use of technology. These are all means with which we can extract information. There's games that have been designed to do similar things. And so based on that, we need to go to design, and I'll stop my talk right here. Thank you.